So, back to having a think about my little battery situation here. So I've got these capacitors. This is the battery off the bike, so obviously I need to make sure I stay within this size. Well, I've done a few drawings here. It's the width of the battery. Here's the top up to this lower point where the terminals are. This is the top above where the terminals sit. Here's a side view on. Well, measuring the caps, I could have actually stacked them, so if this was looking at the battery from this way on, I could go 2 wide, 6 high, and I can actually go 4 deep. Well, that is actually more capacitors than I have. So the final arrangement I've come up with is basically each layer will be 8 capacitors like this, and I stack them 5 high. Going to connect them. I'm going to put the negative terminals, parallel them up, have them external to the bank, have the positive terminals all on the internal side. Do you know what I mean? If somehow the outside comes into contact with the bike frame, it's not going to hurt anything because they're the negative side. So yeah, I've got some I'm not entirely sure what it's. I think it's bronze, brass, maybe. It's a gas welding rod, but it's for brazing. It's not fluxed or anything. So I've got that. I've got a couple of terminals. The screws actually fit these perfectly. They're like the exact same size. So I'm thinking I can put individual wires on the various layers and bring them all up. So maybe I've got 4 or 5 wires, however many it works out to, going into each terminal, so the current load's going to be split. So it's a nice, you can see it's a nice wide terminal. So you know, several small wires all working together will act as one big wire. So I'm going to have a little bit of a solder here, and these looks like they're going to be fiddly to work with. I've got to figure out what to put it in. I don't know whether to put it in just like an old Chinese tub or sandwich tub or something. So yeah, anyway, I'll see what I come up with in a bit. So I just started soldering these up, and so I'd soldered them into blocks of 2 paralleled. So you can see, look, the minuses together, the pluses together, same again, same again, same again, same again. And I've just started stacking them into a pile, and it's not till I've just got to this outside edge I've realised I've connected the bloody things up the wrong way round. The negatives are all supposed to go into the middle, and the positives, well, negatives to the outside, positives to the middle. So I've just twisted and soldered these connections to make sure they was a good joint. And so now I'm going to have to cut them, and annoyingly I've cut off the excess leads as well. So I'm now going to have to get creative with this stuff, or some wire or something, to try and reconnect them back together again after I've cut them and took them apart. Sod's law, it was bound to happen. It was all just going too well. I thought this isn't going to take too long. This is relatively easy. Just keep repeating these steps a few times and we'll be done. So yeah, it happens. Well, you can see where I'm going with this now. So I keep soldering the capacitors up like this. You can see a little twist, one lead round the other, and solder it. Focus, thank you. So yeah, that's 2 parallel capacitors, 2, then all the positive terminals are getting soldered together, all the negative terminals are getting soldered together. Here's some of that welding rod. This is you can see it's in little bends here and there. It's helps connect all the positives together. It's just adding a bit of rigidity to them. These outside ones aren't too bad because the way I can connect them a bit easier than obviously trying to twist the leads together on the inner ones. They're quite rigid. I might put a bit of this in on the outside as well. I'm not sure. Seeing here soldering all these together, it is quite a lengthy process. So I think what I'm going to try and do is I'm going to get another these on here, make this 4 high, probably 5 high or 4 high, and I might then pack some I think probably the best bet is go 4 high and then pack some sort of this way on around the outside. I'm not going to get as many caps on doing it that way. It's just going to be a lot easier to solder it together. It's going to be a lot more rigid as well. So I think when I got the 5 on here, I'm just going to go charge these up and just see, you know, what kind of energy I can get from them. It's not a lot. I mean, these are power supply capacitors. Now, I've seen a few people do this with these big super caps. Well, they've come a long way in recent years. They used to be purely for memory storage. If you looked at the data sheets, they was rated for a few milliamps, some less than even a milliamp. They was really designed for slow charge and very long slow discharge applications. Well, the new ones I've been looking at, some like say these 3 volt 10 farad caps, actually have short-term peak current ratings of sort of 50-60 amps, which is just incredible. And obviously you'd probably series about 5 of them together, that would give you 15 volts. You'd be pushing your maximum voltage limit. But yeah, they'd certainly provide the current. I don't know how long they would last, because it does say on the data sheets they are designed only for short-term occasional use like that. I think the rest of the time they're more for the old memory storage. If you had like a program running and the power went down, basically all of your CPU, or you say it's like a little PIC or something, were completely shut down, and basically it was just purely there to just keep power to the device for memory, so all the RAM files and stuff with the volatile memory wouldn't get lost. These bigger ones, what they allow now is, say you might have something which is trying to keep count of the amount of times, like, I don't know, maybe a car drives over a strip in a car park or something, anything like that. If power's lost, say you've got like various other little peripherals which are being run from that processor, they'll shut down, but the processor itself is still going to be able to keep running. It's still going to be able to keep counting events or taking note of something, so that when power returns it can deal with it. And I think that's primarily what these big super caps now are really intended for. Now, like I said, I've seen some videos, people using them to start cars and all sorts, which I you know, if you'd asked me if that would work, I would have pretty much said no. Obviously these are nowhere near, like these are only 4,700 microfarads, so if I use all of these it only comes out to 188,000 microfarads, which is not even a fifth of a farad. It's not a great amount of energy, but what these can do, these will just last indefinitely. These can supply huge amounts of current in either direction. They can either sink huge amounts of current into them or source huge amounts of current to a load. But when they're in use as well, it's not just about the initial current coming from or going to them, it's the constant ripple on them when you're using them, obviously on a vehicle. Especially on something like the little bike these are going on, the current from the stator it's only single phase, so it's not very constant. It's up and down, up and down. These are having to take over, to take that ripple and turn it into a constant DC voltage and current for the lights and stuff to use. So these are certainly going to be well suited to that, but for actual physical energy storage when the vehicle's not running, I'm not holding much hope for them really. Well, so I'm going to get another 2 on here, or 4 on here, whatever, and just give them a little test, see if they'll even light a light bulb for a few seconds or something. So yeah, anyway, see what happens. So right, I've got 22 caps in this pile now, all paralleled up. So I've still got a few left. Well, they're quite fiddly, I'm not going to lie. You can see I've ended up with just 3 rather than 4 on this section here. So I'm happy with this. Because I've still got to try and figure out how to put something around it. It's no good just having it floating around loose in the side of the bike there. So obviously the more I put in, the less space I've got to work with to try and put something around them. So I'm going to solder some wires onto this, solder some connections onto it, and put it onto the bike. Well, I've got a few caps left, which is no great shame, because I've actually got another little project on the way. It's a Class A amp, MOSFET one. I shall be uploading that when time comes. Got a lot of work to do on it though between now and then. So you know, these are going to come in handy on that. You class A amp, it's going to be drawing sort of 4 or 5 amps maybe. I don't know. It's going to be drawing a good chunk of current constantly off the power supply whilst it's running. So these will come in handy for that. You know, any other future projects as well. So you know, for the few quid I paid for these, 9 quid or something. So I'm going to stuck this on, give it a whirl, see how she goes. Alright, so by pure chance, just scouting around in my cupboard, and this small plastic container happens to just fit these in beautifully and not rattling around. If you look, not a million miles different from the size of the original battery. If I'd known I'd had this, or if I'd thought about it a bit more, I'd have drilled some holes in it and brought the wires through, but I'd already soldered everything in place and I thought I'm not chopping them off, so I've just put a few little grooves in the side of the lid. This lead should be long enough. If not, I can always just put a groove in this little clip that goes down here, but I think it's long enough. So anyway, I'm going to go put this on the bike and see what happens. So here it is on the bike. You can see it just fits in there. This flasher terminal, even with the proper battery in, there wasn't really enough room to feed it in here. It was all squashed in and not in properly. Well, this case just sticks out a little bit more on this clip. It pushes against here, and this won't fit in, but I've just put it in there. Obviously, I'm just going to put a bit of tape around the terminals, but you can see I just soldered some big lugs onto there, and they just screw on the normal way. Bike is currently running. There's the little clone of the Honda Cub engine. Well, the bike itself is a, you know, it's I don't know, just a Chinese motorcycle of motorcycliness. See, at the minute I've just got the side light on. You can see even on idle there's enough power for that. If we turn to main headlight, see, once there's a few revs on, it's fine. Just dims down after a second with the revs off. The run indicators again, so you know, even on idle it'll flash the indicators. Well, when I'm going along, it's fine. So yeah, as I suspected, there's just not enough power from this to start the bike. It'll barely run the neutral light for a few seconds. You watch, if I kill the engine, all the lights off. And there it goes. So yeah, it stores enough energy as I want it to run the bike, allow me to run the bike, and obviously just smooth out the power, because we're running without a battery. I'd just be blowing bulbs, and you know, headlight would be really dim if it wasn't, because it's just all over the place. So CDI on this is a separate system to the battery, so even if the battery's flat, so one quick kick, job done. It makes no difference to it. So yeah, I'm happy with that. Anyway, saves me going out and buying a new battery, which will only get ruined. So yeah, in the end there's 22 capacitors in there, and they just fit in nicely. So that'll do.